Hello all, welcome to the Docker session 2 on Docker in Action series. I am Anjum Dominic, Principal Consultant of Quadralogics. I will be the trainer for this session. Hope I am audible to you. If I am audible, kindly ping me so that I can get assured that you are all able to hear me properly. Let's wait for another 2 more minutes to start. Let's wait if someone else is also joining in. Okay, so let's start our session. So this is session 2 in the Docker in Action series. Yesterday we covered some of the basic concepts of Docker, like we checked out what is containers, what is virtualization, what is Docker container platform. We created images for our applications and we pushed into Docker Hub. So these are the basic topics that was covered in the first session. So in this session we will be covering mostly about the Docker volumes, compose files and Docker swarms. So what is Docker volumes? In the normal case, when you create a container and when you exit the container, all the data stored, like suppose if you are containerizing a DB application and you have some data in the DB, all those details will be lost if you exit that container. Containers does not persist its data. So if you want the container to persist data, you have to use Docker volumes. There are 3 types of Docker volumes available in the Docker. That is, first one is volume mount, and the second one is bind mount, and the third one is TMPFS mounting. So mostly preferred one is the Docker volumes. Docker volume is that a part in the Docker container area will be having all the contents of whatever we are doing in the containerized application, and that will be stored there permanently, and no non-Docker processes can modify that particular data. That remains there persistently. So that is how we make use of Docker volumes. But in the case of bind mount, we can have any physical location. That is, all the data in the container application could be stored in any physical location. Like if you take your documents folder, you create a folder name. Say if I am creating a folder in my name Anju, you can store all the data in that Anju folder. So that kind of mounting is called bind mounting. But there is always some security issue. That is, non-Docker processes can also modify this data. We can't be assured that only the containers are modifying the data. So the mostly preferred technique is the Docker volume mounting. And the third technique is the TMPFS mounting. That is where the data will not be stored permanently. The data will be stored only in the memory. So if you exit the container, the data will be lost. So we will be focusing on the Docker volume mounting. So let's go to our terminal. So here I have taken a cloud instance. I have taken a Vultr cloud instance. I have taken Docker training 19, that is my server name. So I am going to log into that cloud instance. I have already given the hostname details in the etc host file. So I can very well use the name of the server to get connected to the cloud instance. So my name will be Docker training 19. So we are into the cloud instance now, and let's see if any of the containers are running. Docker ps command will show any of the containers. There are no containers at the time being, and if you give docker ps -a, there are no containers at all, so it is a clean slate, so we don't have any containers running there. Now let's run a container, a Jenkins container. Jenkins container, as you know, it is an integration automation server. So we have the Jenkins image available in the Docker Hub. Official image is available in the Docker Hub. So you can very well go and take the Jenkins image from the Docker Hub. So let's run the Docker Jenkins image. You use the command docker run. I'm going to give a name for my container as my Jenkins 1, and Jenkins will be running on port 80 in the containers. So I am going to map the container port 80 with the container with the port number 8080 of the Docker host. So we have seen this already in the last session. If you have any doubts, please refer the previous session. So we are going to do a port mapping here where 8080 port of the Docker host will be mapped onto the 80 port number 80 of the container, and also we will use like 50,000, that is another port number in the Docker host. I'm going to map the 50,000 port of the container to 50,000 of the Docker host. This is for my API applications, and now I'm going to run the Jenkins image. That means I'm going to create the container with the Jenkins image, and I'm going to run the container. So it is pulling down the image. So it will take some time to pull down all the images. So let's wait until it completes the pulling down of the images. It will take some time. So Jenkins image will be probably a bigger image, so it is pulling down all the layers of the image, and then so now the Jenkins server is on. So let's go to the URL and see the Jenkins dashboard. So here also you can use HTTP. You can give the name of the server where I am running the Jenkins, port 8080. Is it 8080 or 8085? Let me check my host file once again. I gave another terminal, or let me just log in with my IP address directly. So it's again I'm unable to connect. So let me see if the container is running. Let me just kill this container and run it once again. So let me give 880. It is taking some time to, yeah, it is getting connected to the Jenkins. It will take some time to log in. Okay, it is taking unwanted time, so let me try out in another of the cloud instance for the timing. So I'll just exit this one and take another cloud instance. So let me just stop this container, so by logging into okay, so then the container is down now. So now let's go and log into my another cloud instance. Okay, so I'm going to log into my another cloud instance. So let me try out. So we lost some amount of time, so I'll just directly go into the volumes. So I'm going to create a volume here, docker volume create. I'm going to give the name of the volume as my vol. So if I give docker volume inspect, if I give my vol, you will be able to see the my vol path. So this is where the data of the container will be stored permanently. So now again let me run the docker run command. Docker run minus hyphen name my Jenkins 1, and I'm going to give the port number as 8080 and then minus p as 50,000, and here also I'm going to give the volume mount. So I'm going to use the whatever my vol that I have created, my vol, and all the contents which are there in the Jenkins container. So all the details in the Jenkins container will be there in the Jenkins home. So all the details of the Jenkins home container will be stored into the my vol directory. And let me just run this one with the Jenkins image. So now we have attached our volume. So we are going to have all the contents of the Jenkins container in the my vol. Let's see if I can if the data persists even if we delete this container. Okay, now let's go to the URL. So it is asking for the password. So this password, this is the Jenkins dashboard. So first it will ask for the password, and the password is here. This is the password which is randomly generated by the Jenkins server. So I will go to here and paste it here, continue. Then here I won't do any installations. So here I will select none to install just for the time being. So then I will just give a name of the user. You can give any name you want, that is respective, that is for the Jenkins actually. So this has nothing to do with the Docker this thing. I'm just showing you an application. So this is the Jenkins server all set ready. Now I'm going to create some data in this container. So this data will be stored in the my-wall path, and even if you delete this container, that data will persist. So if I create a new job in the Jenkins, say test job, I'm going to create a project here. So I'll give some build script path, say. So even if you don't understand how Jenkins work, it's not an issue, but just understand that this is just to create some data for the container. So we have done some data in the container. So if you go to the Docker training, if you go to the Docker terminal, it is still running, so you will get a new terminal, and I will log into training 20, sorry, docker underscore training 20, training 20. So I have logged into that, and just I am going to see the Docker PS. So Jenkins is running, so I am going to exit the I'm going to remove this container as such. So 7.4. So if I give Docker PS, my Jenkins 1 container is not at all running. So now let's create another container. Say with the name, same command, I'll just give the name of the container as Jenkins 2. And here port number also I will specify something different. So if I give 8081, and I will give 50,001. So again I'm going to create the Jenkins server. So it is still using the my-wall Docker volume. So let's see how the Jenkins is going to specify. So this Jenkins is already deleted. So if I go here, you won't be able to see any data. So here it is 8081 now. So now what is the difference it just showed you? It did not ask for the initial password because that password is already present in the my volume Docker volume. So if we can, and all the user details also, we created a user for the Jenkins. So that is the test user. So that details is also present. So after when you log in also, you will be able to see the test job that we have created with my Jenkins 1 container. So even after my Jenkins 1 container was deleted permanently, that data which was there in the Docker volume mount my-wall is still there, because we used my-wall with the second container my Jenkins 2. So that is the pretty much about the Docker volumes. Now let's move to the next topic, that is Docker Compose files. So before understanding Docker Compose file, let's give you an overview of where this Docker Compose file comes into picture. That is, if you till now we were dealing with a single host and multiple containers. But if you want to have multiple containers deployed simultaneously, that is, if you have an application, if you have a containerized application, different components will be running in different containers. So there should be a mechanism by which all the components, that is all the containers that are present for your application comes up alive simultaneously. So that is where Docker Compose file comes into picture. So if you have multiple containers, both multiple containers could be handled together by writing down the steps in the Docker Compose file. It is mainly written in a Docker Compose YML format. So YML format, you can go out in the internet and check for the YML format and how it looks like. It is basically some spaces. It is mainly written in key value pairs and all. So you will have a key and you have to give the value. So like that it is usually written. You can go out and check for the YML formats. So this Docker Compose file help us to create multiple containers simultaneously, or in other words, you can tell that it helps to create an application stack. So take an example of a voting app. So this is a typical example mainly used for working with Docker trainings. So this voting application is basically having 5 components. First component is a voting app. So that is written in Python, and that will handle the front end or the user interfaces for the voting application. Now whatever vote we have given is stored in a database called Redis, and this Redis is being used by the worker to send the details to another database, which is Postgres database, and that database will give information to the result app. Result application is the another user interface application to print out the voting results. So this is the basic overview of the voting application. So you have the entire voting application will have 5 components: vote, result, and 2 databases, and a worker component. So 5 components make together that voting application, and each of the component works in its own containers, and it is completely different technologies. One is in Python, another is in Node.js, one DB is completely different from the other. So we have 5 entities. So we need to link them together and make them work together. So that is what happens in the Docker Compose file. So this is the basic front end for the application. So you will have 2 options, cats and dogs. You can select whatever option you want, and the output will be shown in this screen. That is 100%. That means I have given only one vote. So cats, I have given the vote for cats. So 100% vote is in the cat side. So this is the result app. So this is how it looks like. So I have this application ready in my GitHub. So if you go to the GitHub example voting application, you will find all the details and each component. See, vote component, these are the app.py is the application that runs the vote app, that is the user interface, the front end user interface for giving the votes. So this application is present in the vote folder, and you can find also the Docker file in the vote folder. So we can create an image for this vote application. And if you go to the other another component, that is the result app, that is showing the result screen. So that there also it is written in Node.js, so you have all the server files, package.json file and all, and here also you have a Docker file that will have all the instructions to create the image for the result application. And then you can have the worker component also. There also you will have all the application files, and also you will have a Docker file to create the image for that particular worker component. So there are 3 images now. One for the front end, that is the user interface for where you cast your vote. So that is one image. Another image for the result app, where the result of your vote is shown, and another image for the worker app that handles the communication between the voting app and the result component. Then you will have two databases, that is basically Redis database and Postgres database. Those images are readily available as official images in the Docker Hub, so we'll be taking directly from there. So let's go to our terminal. So most probably it has timed out, so let me see. So I will just stop this Jenkins server for the time being. Docker ps, I'll go and check for Docker ps. Jenkins is running, so I will use the command stop and remove the container. I'll give the first two digits of the container ID 40, so it is getting deleted, so you don't have any containers running now. So let me see if I have the code here. No, so I will git clone the path. Where is the path? If you go to the Docker examples, you will get the clone path. Okay, you're getting the clone path. So you have, if you go and here, if you have Docker samples, if you go to the Docker examples, and if you give example voting app, you will find all the details. You have some extra files also, but don't worry about those extra files, just worry about these three apps, these three folders. That is a result app that I have already showed you. You have a Docker file, application code and all. Vote component that handles the user interface where you cast the vote. Result application, result component that is the user interface to show the result of the voting. And then worker that actually that application actually communicates or manages the information transportation from the result and the voting app. So now let's go to the result folder and build the image. See Docker build. I'm going to give the image name as result app. So it is creating an image there. So you will have, if you run that image, you will have a container for the result app or result component, that is the user interface where you get the result of your application. So it will take some time. So I'm not going into much details about the Docker file. So Docker file is already present in our path. So our image result app is created. Now let's go to the vote folder and create an image there. Docker build. And I'm going to give the name as voting app. So it is again creating the image in the voter component image, voting component image. So it is created. Now let's go to the worker folder and create a image there. And I'm going to name the image as worker itself. It will take some time to pull down all the images and all to perform all the steps in the build or Docker file. So let's wait until it completes the worker image also. And if you give Docker image list, you should be able to see all the images that we have just created. Okay, so if you give Docker image ls, you will be able to see that you will have result app, voting app, and then what worker image also all set. Now let's see for the other two components, Redis and Postgres, you have the default images in Docker Hub, so we'll be just pulling down that from there, so we won't be creating the image locally here now. So let's write a compose file so that the entire application stack will be up and running and you will get the application on your browser. So for that, what you have to do is go to the main path, and I am going to create a Docker compose file. Docker compose .yml file. So this is the YML file. So the first thing I am going to insert is that the Redis. So I am going to enter the Redis details. So what is the image I am going to use? I am going to use Redis image itself. So just the space is an important issue in the YML file, so just be careful about how you give the space. Image Redis. And now what is the next thing that you want to have? You need to have say I'm going to name the container as DB, so that is the DB is for the Postgres container. So image, I'm going to use the Postgres image, and the next one is voting component. So I'm going to use the space, I will arrange it later. So first image, what I'm going to write is that voting app. I'm going to use the image as voting app. Now the next one is not the vote, the other one is result app. Result app. So let me just result app. So what is the image there? I'm going to write the image as, what is the image? Result app. So these are the four, and you have one more component, that is the worker component. So I'm going to write the worker worker. So what is the image being used in the worker component? That is the worker image itself. So now we have all the images ready with the applications, but you need to have some details also appended with this all these sections. So if you take the result app, what are the ports, or through which port the application will give the output. So you have to specify the port number also in the result app. So here one more thing you have to give, you have to specify the ports. So I'm going to specify it as ports hyphen p hyphen, what does it is 5001. So that is the port number for the result application to give its output. Similarly, in the case of voting application, you will have to have ports hyphen 5000. So these are the ports numbers for the different images, voting app and the result app. Now the one other thing you have to find out is what is the links that you need to give. So if you let me see that one. Links. So if you go to the terminal, you have to give the links, that is voting application depends upon the Redis container. So you have to specify the links as it is linked to Redis. Now okay, now what about the result app? Result app also depends upon the Postgres database, which is the DB database. So here again I will give links. Links as DB. Now what about the worker image? So worker component depends on both DB and the Redis database. So here I will be using DB and Redis. So this is how it is connected. So now let's give a save it. So now ideally we have to give docker compose up command to run this application stack, but docker compose does not come with the inbuilt docker installation, so we have to install it separately. So you can go to the documentation and see the install docker compose. If you can search for install docker compose, you will see different ways you can install docker compose in different servers. So I'll be using Linux, so I'm going with the Linux command. So this is typically the command to run the or to install docker compose. So let me go to my application and then install the docker compose. So let me install docker compose and have to also specify the permissions for the docker compose script. It is actually a script. So here it is finished. So now let me just give the permissions for the docker compose script. Now if you perform docker compose up, what it will show us? Docker compose up command. So it is pulling down the Redis image. We don't have the Redis image locally, so it is pulling down the Redis image. So it is pulling down the Postgres image. and then let me see what all other images are present locally in our system also. So you are creating the Docker stack, and now it is up and running. All the connections are also established. So if you go to, so I'll just verify this one, as if you take 5000, it is telling us we are having some troubles. So let me see if the all other applications are running. So I'll just close this terminal and take another terminal. Sorry, Docker PS. So if you go to Docker PS, you can see the worker container is running, voting app container is running, and result app container is also running, and the Postgres application is also running, Redis application is also running. But there is some issue with the port mapping. It is not mapped correctly. So let me see if I have missed out any commands in the, so let me stop all these containers and remove all these containers. F2, then 6b, then F1. So D6, 5.2, 6b, F1, and 90. So 90. So we have all the commands ready now. So let me see my Docker Compose file. vim docker compose.yml. And let me see the I forgot to give the port number here. So here you have to specify, this is the Docker host port number, but you have to specify the container port number also here, by as in the case you give with -p. So this is 80. And what is this one? Sorry, this is 5001 with 80 itself, I guess. 5001 and 80. So that port mapping is correct now. So let me save this one and give the Docker Compose up command. So now all the images are there, so it will not take much time. And let me just go to the 5000. Sorry, you have to give Docker training 20. So this is the output of the screen. You can very well take, say if you take docs, I have casted my vote to docs, and if you give 5001, you will be able to see that 100% vote is for the docs. So this is the typical example for Docker Compose file. So many containers got alive together with the help of Docker Compose file. So that is about the Docker Compose. So let's stop all the containers. Docker appears. And now let's move on to another important topic, that is the Docker Swarm. Docker Swarm itself is a big topic, so I will just give you the fundamentals of what is Docker containers. What are the Docker swarms actually. So I have deleted all the containers. So now done. So now let's move to the Docker volumes. Docker swarms typically. So here I am going to use another server, which is a Docker master server. So I have 3 servers. So here, that is Docker master server, Docker training 19 and Docker training 20. These are similar instances taken from the cloud. You can name in whatever way you want. I have just named like this. So Docker Swarm is like a cluster of Docker host. So till now we dealt with one single Docker host and one container. Then we dealt with one single Docker host and multiple containers. Now we are dealing with multiple Docker host and multiple containers. So Docker Swarm is like a cluster of Docker host, and in that cluster some of them will work as the manager nodes and others will work as worker nodes. Manager nodes has the capacity to control all the load balancing and everything that happens in the Docker Swarm. And in actually, if you have 7 manager nodes, or if you have 3 manager nodes, one of them will be chosen as a leader manager node. That is with some consensus, Raft consensus algorithm. We won't be going into much details of that. Just understand that one of them will be the leader manager node. And if you want to have another node added to a node to the swarm, this leader node takes a decision. But if leader node goes down, the whatever remaining manager nodes you have, they can come for a consensus and elect a leader from them also. So that depends upon the Raft consensus algorithm. So here I am going to log into a cloud instance called as Docker master, and there I am going to initialize a swarm. So this is the Docker master. So I have logged into the Docker master. I am going to create a Docker swarm. So this will be acting as the leader node in the Docker swarm. So I am going to create Docker swarm init. So this a swarm got initialized here. Now if you want to add a worker node to this Docker swarm, you can use this command. This is already specified by the whenever you give the Docker swarm init itself, it supplies us with the token expression to add the worker node as well. So if you take the training as, say, if you go to the new terminal and just I will change the color. So this will be the Nextcloud instance that will be joining as the worker node in the Docker swarm. So Docker, I am going to use the training 20 cloud instance. So here I am going to join this. I will just zoom in a little bit so that you can view it properly. Okay. So now here, this command, I will just copy this command and then make it run in my first node. So this is the node. So if we go here, see the training 20, that cloud is added as a worker node in the Docker swarm. So if you go to the first, that is the Docker master, and if you give Docker node ls, you will be able to see that you have two nodes now. One is the leader node where the swarm was initialized, and the other is the worker node. And now let's also add another node. So I have one more cloud instance with me, that is training 19. So I will be, let's view, just zoom a little bit, and then I will use another color, say node 2. So here SSH root at docker training, I think it is 19. There also I am going to add the token. So this node also joined as the worker node. So if you go to the docker master now, and if you give docker node ls, you will be able to see that we have two nodes here. Now if you want to promote a worker node to the manager node, we can vary all the actions, that is all the containers could be run in any nodes, either in manager node and also in the worker node. But there is an option for the manager node not to run the containers, that could be specified by the availability as drain flag while joining the swarm. So that can also be done. So here I'm going to promote one of the worker node as the manager node. So how to do that? Let's go to the docker 20 and then docker node promote, give the name of the docker node docker training 20. Okay, I have to do this particular command in the master, then only it could be run. So if you go to docker master and if you give paste, so docker training 20 is promoted as one of the manager nodes. So if I give docker node ls, you will be seeing that you have a leader node, that is a docker master where the swarm was initialized, and another node with status as reachable, that means it is also a manager node but it is not a leader node. And you will have training 19, another cloud instance which is a worker node. So let me just promote that also into a manager node. So that is also promoted as the manager node. So if you go node ls, everything is manager node now. So in a Docker Swarm, there is something you need to make it as a rule, is that it has to satisfy quorum. Quorum is the majority that needs to accept a decision. That is, if you have 3 manager nodes, at least 2 of them should come to a conclusion, or that is 2 of them should agree to a particular decision. That is, if the leader node wants to add a new worker node to the Docker Swarm, that needs to be approved by at least 2 manager nodes if there are a total of 3 manager nodes in the Docker Swarm. So there is actually a formula for that. That is, if the total number of manager nodes is 3 divided into half, that is 3 divided by 2, 1.5 plus 1, 2.5, that we will round about to 2. So 2 manager nodes should accept the decision. Then only the new worker node could be added to the Docker Swarm. So, but if you have the how to deploy the containers to this Docker Swarm. So for that you use Docker services. So if you give Docker service create, so you want to create a 5 instances of Nginx server. So you need to have 5 instances of Nginx server, or the 5 instances of the Nginx container to be run on the Docker Swarm. What you can do is that you can use the command docker service create, and you can give the instances, that is replicas if equal to say 5, and you can give the image that is used for creating the Nginx container. So if you do like that, this Docker master will allocate 5 instances of the Nginx container to be deployed across the Docker swarm. So see, it will take some time to start the instances. So we have 5 instances. So these 5 instances are going to be, so if you give Docker service ls, so that will be the service, that is, this is the name of the service, Peaceful Moss, and it is the ID of the service. You have 5 instances. That service is having 5 Nginx containers running, and let's see where it is running. So if you give Docker service ps and give the first 2 digit of the service, you will be able to see the first instance is running on Docker training 19, another instance is running on Docker training 20, another instance on Docker 19, and another instance is on Docker master. So the swarm itself will take care of allocation of these instances to various Docker hosts. You don't have to worry about that. Even if one of the Docker, suppose if you go to the one of the terminals, say Docker training 20, I think it has gone down, so let me close this terminal. It has timed out. So let me take another new terminal, and if you take SSH into root at Docker training 19, and if you are going to shut down here, shut down some, due to some reasons it got shut down or it just went down, shut down now. So what it will do, it will get shut down. What is the after effect it will have on this command? It will take some time to come into action, so let's wait for some time. So now what it happened? So one of the Docker training 19 is shut down, but you need to have 5 instances running simultaneously. So whatever instances was running on Docker training 19, it is now handled by Docker master itself. So we have 3 instances running in the Docker master, and I think, how many instances are running on Docker master? 1 instance and 2 instance, 3 instances running on Docker master, and 2 instances running on Docker training. So even if one of the Docker host in one of the Docker swarms comes down, the orchestrator in the Docker swarm will take care of allocating the instances running on that particular down server and allocate it into other nodes or other Docker host. So that is the main purpose of Docker swarm. So let me see if we have any questions. I did not get time much to see about the questions. Okay, what are the main difference between the Docker Jenkins, why we need 2 ports? That is specific to the Jenkins application. Jenkins application uses like interfaces, all the APIs will be handled in different port. That depends upon the application. So in some of the application you don't have to specify 2 ports. So what if any application is using 2 kind of ports for different applications? Say for interfaces you are using different port, for other applications you are using another port, then only you need to specify 2 ports. And mainly the Docker Compose file is mainly used, as I said before, if you have if you have an application, it is divided into 5 components. Each of the component is working in its own container. That is, suppose if you take the example of the voting app itself, you have 5 component. First is the vote component, that will handle the interface to cast our votes. The second one is the result app, that is the that will handle the interface that gives the output of the vote casted. And the third one is the worker component that handles the communication between the vote app and the result app. Then you have two DBs, Redis DB and the Postgres DB. So this 5 components you have in an application. So in the normal case, if you want to have 5 containers running, you have to give Docker run Postgres, Docker run Redis, Docker run worker image, Docker run voting app, Docker run result app. But so you have to run each time Docker run. And also after running the Docker container, after running the Docker container, you have to link them together. Then only the entire application stack will be up. This burden is avoided while using Docker Compose file. Docker Compose file, there is inbuilt commands to link between different containers and also start multiple containers together. So hope I am clear to you. If there are any other questions, kindly let me know. I think I have almost 1 hour is over, so if you have any doubts, quickly let me know. Any doubts? So this is how basically you run with the terminals, run with the Docker Swarm. Any more doubts? If you can try doing it yourself during your free time, and if you have any doubts or any confusions, you can let me know in anjudominic@quadralogics.com. So that is all from me for this session. Hope you have enjoyed this session. Kindly let me know the feedback at anjudominic@quadralogics.com, or let me know in the LinkedIn also. So happy to see you all attend this session. So tomorrow we have another session related to the Docker security concepts. So thank you very much once again. Have a great day.